Bismillahirrahmanirrahim. Now we'll start chapter 7, section 7.2, matrices and linear systems. What they mean by a matrix valued function or matrix function is a matrix is that its component are functions. Huh? These are functions of T. Okay. Each entry is a function of T. Continuous or differentiable if every element is continuous or differentiable. How to do the derivative of that matrix? Just we'll do it element-wise. We'll do the differentiation of each element. And we have some formulas. The derivative of the sum of two matrices is the derivative of the first plus the derivative of the second. A constant, a value. It's just a value, you can take the value outside. If it is a vector, the same thing, I take the vector outside. Vector from the other side, the same thing. If I have a matrix times vector, then it will go on the other side. Okay. Now, this is the most important derivative of the product. Be careful because the order is very important. It will be the first matrix times derivative of the second plus the derivative of the first times the second one. You need to be careful about the order. If this is x of t, a vector or a matrix, what will be x prime? Just you will do the derivative of the terms. Derivative of t is 1, t squared is 2t, minus e is minus t. What will be a prime of t for this function? That will be cosine t, 0, 1 minus sine t. Okay. Now this is a question in the book. Verify the product law for differentiation. Okay. So you want me to check a, b, the derivative of the product of two matrices is the derivative of the first times the second plus the first derivative of the second. Okay, so let me do first one. A prime of t will be what? Will be 1, then 2, 3t square minus 1 over t square. Okay, b prime of t will be what? Minus 1, 1, 60, 12t square. Okay, now we'll check the left hand side, which is AB derivative. What I will do, I'll find the product of the two matrices. Product of the two matrices. So we have t, 2t minus 1, t cubed, 1 over t, times this matrix, 1 minus t, 1 plus t, 3t square, 4t cubed. Then I'll do the derivative. That give me what? What's the product of these two matrices? Yeah. T times 1 minus t, that is 1 minus t square. That is t minus t square, sorry. That is t minus t square. Multiply this element by this element, and this element by this, plus 6t cubed minus 3t square. Okay. Now multiply the first row by the second column. The result is here. So I have t plus t square plus 12t cubed minus 4t cubed. Plus 12t to the power 4, sorry. Yeah, plus 12t to the power 4 minus 4t cubed. After that, I will do the derivative. Okay. Now, what is the result here? T cubed times this. That will be t cubed minus t to the power 4. Plus 1 over t plus 1. 1 over t times this. Give me plus 1. Now, multiply this. No, be careful, be careful. What is this? Multiply this row by this column. So it will be plus 3t. This element by this element, and this element by this element. I multiply the row by the column. Okay. Now multiply the row by the column. That will be t cubed plus t to the power 4. Then this times that plus 4t square. Then I need to find now the derivative. That will be what? derivative, it means I need to write the derivative of each term. T, I have only T, I have 1, minus T squared, minus 3T squared, minus 4T squared, so that will be minus 8T plus 18T squared. This one, I have 1, yeah, plus 40, plus 2T. Yeah, I need to make it arranged, so that will be easy for me to follow. 1 plus 2T. Then I have minus 12T squared plus 48T cubed. Then I close it. This one, I have 3 plus 3T squared minus 4T cubed. Okay. This one, I have 8T plus 3T squared plus 4T cubed. Okay. This is the left-hand side. Now we'll come to the right-hand side. Right-hand side. That is what? A prime B plus A B prime equals to what? So let me do A prime B. A prime B. That will be what? A prime, this is A prime 1, 2, 3T squared minus 1 over T squared times B. What is B? This is B. 1 minus T, 1 plus T, 3T squared, 4T cubed. That give me what? 1 minus T. This row times this column plus 6T squared. Okay. Okay. Now I need to multiply this by this. I have 1 plus T. Okay. 1 plus T times what? Times 1 plus T plus 8T cubed. Okay. Now this one I have what? 3T squared minus 3T cubed. Yeah. Minus 3. Okay. Yeah. Okay, this one times this, I have 3T squared plus 3T cubed minus 4T. Okay, this is A prime B. Now let me do A prime. That will be what? A, what is A? T, 2T minus 1, T cubed, 1 over T. This is A. Times B prime. This is B prime minus 1, 1, 6T, 12T squared. Let me do the calculation. That will be what? Yeah, this time this, that is minus T plus 12T squared plus 12T squared. Yeah, minus 6T. Okay, let us see. Let us look what happened. Okay. Now, yeah, minus T, 12T squared minus T minus 60. Okay. Then this row times this column, I have T plus 24T cubed minus 12T squared. Then T cubed, this is minus T cubed plus 6. This times this give me plus 6. Is it plus or minus? It's plus. Yeah. I have 3t squared, so it's 60. Okay. It's a matter of calculation. Now I'm just doing it. T cubed plus 12t plus 12t. Now I need a prime b plus ab prime. That will be what? I need this plus this. Be careful. I have 1 minus 2t. 1 minus 2t. Not minus 2t, minus 8t. I have minus t, minus 60, minus 70, minus 8. This is minus 8t plus 18 t squared. Exactly this one. Perfect. So this is, until now it's a square. Okay. Now I need this with this. I have 1 plus 2t. I have minus 12t square plus 3. That will be no, minus 12 square, correct? Minus 12t square plus 32t cubed. Plus, yeah, here it is 48. Why is 48? Because I need this one comes from where? I have 12t to the power 4. Yeah, that is 48. There's a mistake somewhere here. Plus 8 plus 24 is plus 32t cubed. Okay. Now this one, I will look at it later. Minus 3 plus 6, that's 3. Minus 3 plus 6. 3t square plus 3t square. I have minus t cubed minus 3t cubed minus 4t cubed. Perfect. Now this one plus this, I have minus 3t. Ouch. I have minus 4t. Oh, sorry. I need to add this with this. So I have minus 4t plus 12t, 8t. T cubed plus 3t square. Plus 3t square plus 4t cubed. So everything is okay except this, or this. Yeah, let me try to figure out what is the mistake, which is not easy to do. Yeah, I have this times this one. So I have this times this. So I have 8t cubed. 80. Yeah, sorry. This is 8. Here is the mistake. 2 times 4. That will be 8. So that will be 32. So this is correct. Now this one equal this one. Yeah. This is what he wants us to do. Double check and this is correct. In an exam, if this is coming in an exam, what the question will be, he will tell you, for example, find this, AB all prime. Or he gave you A prime, he gave you something, find the other one. Let me do the second one, just to be sure with the calculation. So I have A times B, left-hand side, I have AB all prime. That will be what? T square minus T0, be careful, 8t minus 1t cubed times B. This is E minus T. This is 3t. That give me what? All prime, huh? That give me this one times this. That will be 3et plus 2t us minus t plus 3t cubed. This time this minus 3t plus 6t. Okay, don't forget all prime, huh? This one will be 24t minus 2 us minus t, huh? Plus 3t to the power 4. Yeah, so that will be what? No, that's the vector. It will be 3et. Here I have quotient and product rule plus 2 us minus t minus 2t us minus t plus 9t square. Okay, then I need to find the derivative, huh? Still, I need to find the derivative. Yeah. This, oh, no, I'm doing the derivative here. I'm getting the answer. This is equal. I'm finding the derivative. This is 3t, so this is 3. This one is what? 24 plus 2 us minus t plus 12 t cubed. Okay, now do the other one, right hand side, which is a prime b plus a b prime. That is equal to what? Oops. So I'll find a prime b. Let me do it in a step. A prime b is what? Did I find a prime? No, not yet. Let me find a prime. A prime will be et 1 2t minus 1 0 0 8. This is minus 1, so this is 0 at square. P prime will be 0 minus 2 us minus t 3. Now I need a prime b. A prime b will be what? A prime times b. B, which is this one, 3 2 us minus t 3t. That will be what? This times this. Yeah, it's only one vector. 3et plus 2 us minus t plus 6t square. Okay. This one give me minus 3. Okay. This will be 24 0 plus 9t cubed. Yeah. Now we'll come to a b prime. A b prime. Sorry. Yeah, this is it. Yeah. Yes, yes. A is et t square minus t 0 to 8t minus 1 t cubed times b prime. Where is b prime? This is b prime 0 minus 2 us minus t 3. That will be what? Yeah, minus 2 t us minus t. This is times 0. Give me 0 plus 3t square. Okay, and that will be what? 0 0 6. This is 0 2 us minus t plus 3t cubed. Okay, now I add a prime b plus a b prime. See what will happen. I need to add this with this. So the first term I have 3et, good. 2 us minus t minus 2t is minus t to be in the same way. 3 plus 6 plus 9t squared. The other one, minus 3 plus 6, that will be 3. Now, 24 plus 2 is minus t. 9 plus 3 plus 12 t cubed. Correct. This is AB all prime. Yeah, so this is correct. Yeah, actually, this is just how to deal with the matrix function in general. Okay, now let me go to the main topic. What we have in this section. First, if I have system of equations, this is system of equations. We are having a system. We have system of equations. System. We have these. My variable is these x1s, x1, x2, x3 up to xn. So we make it in this format: dx over t, b of t, x plus f of t. What is x? X is x1, x2 to xn. So what will be x prime, which is dx over dt? That will be x1 prime, x2 prime, xn prime, which is this one. Which is this one. And I have p of t times x. What is b of t? What is x? X is x1, x2, x3. So what is b of t? Is b1 of t, b11 of t, b12 of t, p1n of t. This is p21 of t, p22 of t, p2n of t. And this pn1 of t, pn2 of t, pnn of t. This is times x1, x2, up to xn. And this is this block. Yeah. So I'm getting x prime, the format, x prime equal p of t times x. This is x prime. This is b of t. Yeah, let me write it here, times x. Yeah. It would be good to write it here. This is equal. Plus, what is this? Plus this vector, which is f1 of t until fn of t. And they call this f of t as a vector. So you said write the given system in the form of this matrix expression, in this form. That will be what? I let capital X to be x1, x2. That side, that will be x prime. And this side will be what? 4 minus 3, 6 minus 7 times x1, x2, which is what? 4 minus 3, 6 minus 7 times x. So I have x prime equal this. Okay, so I have x prime equal to this. That will be the format. Yeah. Now I get some problems to doing more problems. Look at number 3. X prime, let me arrange it. I don't have function of x minus 3y. To make it clear, I have y prime equal 3x. I don't have y values. So this is going to write it. I let capital X to be xy. What will be the system? X prime equal. Here I don't have coefficient of x, so I have 0 minus 3, 3, no coefficient of y, times x. Part 4, which is easier. I have x prime equal to x minus 5y. Let me put it, yeah, when I make them under each other, that will be easier. I let capital X to be xy. So I have x prime 2 minus 5, 3, 8 times x. I think they are very clear. More problems where we have now homogeneous parts. Okay. What do you want? This one. Write the given system in the given form. Okay. Yeah. Yeah, this is t, huh? I want to write what is this. This is tx. Let me write it again. So I have x prime equal tx minus e to the power ty plus cosine of t. This is y prime. It's e minus tx plus t square y minus sine t. So I let capital X to be xy. So what I have x prime. Huh? This is be x prime equal what? This is times x, which is xy. So I have t minus et. This is e minus et. This is t squared plus the right-hand side, which is cosine t minus sine t. Yes, exactly. So this one, let me write it under each other. Plus 1 y prime. Be careful here. I don't have y value, so that will be minus 3z. So that will make it clear for me. Z prime, I don't have x value, 2y minus d plus t squared. So now I have three variables, so I let my capital X to be x, y, z. So I have x prime equal, I have 7 minus 6, 5, 4, 0, minus 3, 0, 2, minus 1 times x plus the right hand side, which is 1t t squared. Yes, 1t t squared. Yeah. Yeah, I think it's very clear. It's an easy one. More. I have 4 now. So let me write them. x1 prime. I don't have x1. I have x2 plus x3. I don't have x4 plus 1. I think this way it will make it more clear for me. x2 prime. I have x3 plus x4 plus t. x3 prime. That will be x1 plus x4 plus t squared. x4 prime. That will be x1 plus x2 plus t cubed. Yeah. Now I let capital X to be x1, x2, x3, x4. So it will be the system x prime equals what that will be 0, 1, 1, 0. This is times x. I have 0, 0. I don't have x1, I don't have x2. 1, 1, 1, 1. Then I have 1, 0, 0. Then I have x4 is 1. The last one, the last row, 1, 1, 0, 0. What will be the right hand side? Or the non-homogeneous part? 1 t square t cubed. Yeah. Okay. Okay. So this is the way to deal with the system. This is the way to deal with the system. Usually we write the system in this way, then we work it out. Like what we did in the pre-calculus, like in the prepare, where first we need to rewrite the system in a way, in a matrix form. Then we'll deal with the matrices, which we will do in the next sections. A solution of equation 1. What do we mean by a solution of this equation? On the open interval is a column vector function. I have column vector x of t. I'm looking for this x. This is what I'm looking for. So that the component function of x satisfy the system. So if I substitute this vector in this equation, I'm getting the left-hand side is equal to the right-hand side. That's mainly the things. Okay, so this is the question. Verify that the vectors are solution of this system. Look what this is the system. I let x equal xy. So the system will be what? X1, X2. Sorry, I have X1, X2. Yeah, these are just the way here present the variables. So you have x prime 4 minus 3, 6 minus 7 times x. So how to check? This is a solution. First check x1, 3e2t, 2e2t is a solution. How to check that? Left-hand side equal right-hand side, satisfying this equation. So left-hand side, which is capital X prime, that will be what? No, sorry. Yeah, it will be 6 e2t, and this is 4 e2t. This is the left-hand side. Right-hand side, that will be what? Right-hand side, it is a x1, huh? Call it x1. Let me call it, yeah, x1. x1, that will be 4 minus 3, 6 minus 7 times x1. X1 is what? 3 e2t, 2 e2t. That will give me what? Yeah, let me do it here. 12 e2t minus 6 e2t. Sorry. Yeah. Let me do it here. That will be equal 12 e2t minus 6 e2t. Then I have 18 e2t minus 14 e2t. And that will be what? 6 e2t. 18 minus 14, that will be 4 e2t. Note, yeah, this one is the same as this one. So I have x1 prime equal a x1. So it's a solution. So x1 is a solution. Satisfy the differential or the system of differential equation. Okay. That will it work out x2. Now for x2. x2 is what? E is minus 5t. 3e minus 5t. I need to find the left-hand side, which is x2 prime. That will be what? Minus 5. E is minus 5t. Minus 15. E is minus 5t. Okay. Right-hand side, that will be what? A x2. A is 4 minus 3, 6 minus 7 times x2. What is x2? It's e minus 5t. 3 is minus 5t. That will be what? 4, I'm doing it in details, no problem. Minus 9 is minus 5t. 6 e minus 5t minus 21 is minus 5t. That give me what? Minus 5 e minus 5t. 6 minus 21, that is minus 15 e minus 5t. Okay, so very clear to me. This is the same as this. So I have x2 prime is ax2. So x2 is a solution. Okay. But we have more. Yeah, by the way, this is like a written question. In multiple choice, what they will do, they will, for example, they will make this A. They told you it's a solution, find A. So just do the same calculation, and then you have an equation for A, find it, and that's it. Okay, to investigate the general nature of the solutions. Okay. Now we're dealing with this homogeneous equation, homogeneous system. Okay. Then we have what's called principle of superposition, like what we did in chapter 5. If I have solutions, x1, x2, xn are solutions, then what will happen? You have constants. Then the linear combination is also a solution, like what we did in chapter 5. You notice that we have solutions. Any linear combination is also a solution. Yeah. What he wanted this one, if x1 are the two solutions, he gave us the two solutions, which is we saw them before. Then the linear combination is also a solution. The linear combination, yeah. The linear combination of x1 is what? This is x1, which is this one actually. This is x1. This is x2. So what he's saying, in the linear combination, if you have the linear combination of these two, they are also solution of this system. Yeah, by the way, if you want to write it as a solution, you can write it this way. This is x of t will be what? Do this 3c1 e2t plus c2 e minus 5t. And this is 2c1 e2t plus 3c2 e minus 5t. We call, don't forget, we write the solution x of t as x1 of t, x2 of t. Remember, when we wrote it as a system, when we make it as a system, we make it this way, x equal x1, x2. So my x1 is this function, and this is what they wrote here. So x1 will be this function, will be x1, and this is what they wrote here. And x2 is this one, which is they wrote here. Yeah. Wronskian. Now, how to check these vectors are independent or linear independent or linear dependent? We'll do it through the Wronskian. Suppose that we have solutions. Be careful about the conditions. Suppose that we have solutions. These are solutions, n solutions of an homogeneous system. We're talking about homogeneous system. Okay. And P of t is continuous. Then what I will do, what will be the Wronskian? Just I list the vectors. These are vectors. I list them. Wronskian, x1, x2, xn will be what? The determinant of x1, x2. List them, These are vectors. So just list them until xn. That will be my Wronskian. What they said, if P of t is continuous and these are in solutions, then the Wronskian is either 0 for at every point in that interval, or it's not 0. So I check the Wronskian. If the Wronskian is equal to 0, then they are linearly independent. If they are Wronskian not equal to 0, then they are linearly independent. Okay. Is the question, determine whether the set of functions are linearly independent in this interval. Actually, this function is everywhere defined. We have no problems. So I will do the Wronskian of x1, x2, x. That will be what? 2et, 2et, et, 2e3t, 0, minus e3t. I need to check the determinant. 2e5t, minus 2e5t, e5t. How to deal with this determinant? I know that multiplying a function or constant by determinant is like multiplying a column or multiplying a row, one column or one row. So this one will equal to, I can take e to the power t from the first column as a common factor, e to the power 3t from the second column, and e to the power 5t from the third column. What is the remaining? 2, 2, 1, 2, 0, minus 1, 2, minus 2, 1. And that will be e to the power 90 times this determinant, which I think we can deal with. Yeah, we can deal with easily. Either I make more zeros or I can't do it right away. I say this is E90, huh? Times what? Yeah, I'll do the expansion with the second row since I have zeros. So this is plus, that will be minus 2. Determinant of, I cancel this with this. So I have 2, 2, minus 1, 1. Then this is negative plus, then I have plus 2. Cancel this with this. I have 2, 2, 1, minus 1. That give me what? E to the power 90 times minus 2. 2 minus minus 2, 4, plus 2, minus 2, minus 2, minus 4. What's this? Minus 2 minus minus 2, that will be 4. Yeah, so I'm getting what? Minus 8 minus 8 minus 16 e to the power 90, not equal to 0. So that means x1, x2, x3 are linear independent. This is what I was expecting. They are linearly independent. Are linear independent solutions of this one. Now, the most important, if you have n, let me, yeah, I need to check 3 things. N, and they are linearly independent. Not 3 things. And they are solutions. Yeah, 3 things. 1, if I have differential equation or n, yeah, where the matrix is n by n. So I have 1. I have to check that there are n solutions, n linearly independent, and they are solutions. This is what I need to check. For the homogeneous system, where P of t is n by n, huh? P of t is n by n, is a continuous. If x is a solution, then there exists solutions. These will give me the general solution. These are the general solution of the homogeneous system. Of the homogeneous system, x prime equal x. X prime equal, yeah, let me give it more space. The solution of x prime is using P of t, or P of tx. Okay. What he have? He said, given that the vectors, these vectors, are solutions. So I have 1, 2, 3. And this n is 3 by 3. So I have 3. So this is correct. And they are solutions. Halas. This is correct. So I need to check what? They are linearly independent or not. So I check linearly independent. I need to check x1, x2, x3 are linearly independent. How to do that? Determinant. I think we just did, huh? The same one, huh? 2, 2, 1, 2, 0, minus 2, 0, 1, 2, minus 2, 1. Yeah, I will do it. Do it again. I need to check W, x1, x2, x3. I think it will be the same. That will be, I have ET, these I can take them out, huh? So I have 2 ET. Yeah, let me do it in steps. 2 ET, ET. Then I have minus 2 E3T, 0 E3T, 2 E3T, minus 2, not 3T, this is 5, sorry. This is 5T, minus 2 E5T, E5T. I'll take this out, ET, E3T, E90, خلاص, E90. Determinant of what? 2, 2, 1, minus 2, 0, 1, 2 minus 2, 1. Yeah, I'll do the expansion with the second row, minus 2, this with this, minus 2, 2, 1, 1, plus 2, this with this, 2 minus 2, 1, 1. I think it will be the same. That will be e to the power 90 times what? Yeah, times minus 2, minus 2, minus 2, that will be minus 4. 2, yeah, it will be plus. 2 minus minus 2, that will be 4. That will be 8 plus 8, 16, e to the power 19, that equal to 0. So they are linearly independent. That means what? For me, these are linearly independent. That means the general solution, x of t, will be c1, x1, plus c2, x plus c3, x3. And that is the general solution. That will be c1 times what is 2 et, 2 et, et, plus c2 times what? Minus 2 e3t, 0, e3t, plus c3 times 2 e5t, 2 minus e5t, e5t. Okay. Now I need to find a solution satisfies the initial condition, which means what? I need to find C1, C2, C3. How to do that? I have x at 0 in one side. It is 10, 12, minus 1. In the other side, it's what? Now I'll substitute t at 0, at t equals 0. That means t equals 0. I have what? 2c1 minus 2c2, because e to the power t will be 1, plus 2c3. And this one I have what? 2c1. This is 0. Minus 2c3. And the last things I have what? c1 plus c2 plus c3. Yeah. So I have system of three equations, which is what? 2c1 minus 2c2 plus 2c3. I'm doing it in details, more details, equal to 10. Okay. And they have what? 2c1 minus 2c3 is equal to 12. And they have c1 plus c2 plus c3 is equal to minus 1. I need to solve this system. I need to solve this system. Okay. So I'll do it in the next page. Okay. Let me write the system again. 2c1 minus 2c2 plus 2c3 equals 10. You have three equations, three unknowns. Do it the way you like. 2c1 minus 2c3 equals 12. Correct? Yeah. c1 plus c2 plus c3 equals minus 1. Yeah, you can do it by Gauss elimination. Let me do it by Gauss elimination. By the way, here I can divide by 2. So let me first divide by 2. I have c1 minus c2 plus c3 equals 5. Here I have what? c1 minus c3 equal to 6. And that will be c1 plus c2 plus c3 equal minus 1. You know what? There is no need to do it by Gauss elimination. If you look at it, yeah, you can. Now we have three equations, three unknowns. Try to do it the way you like. I notice here, C1 plus C3, C1, this one give me what? C1 plus C3 equal -1 minus C2. Then I plug it here. So I have what? This is, I have -1 minus C2, which is C1 plus C2, minus C2 equal 5. Now I get rid of everything. So I have -2C2 equal 6. So C2 equal -3. Good. I get C2. Then substitute it. In this one, for example, substitute it here. You have what? I have C1 minus C3 equals 6. I have here C1. C2 is -3 plus C3 equal -1. That means I have C1. As I said, you have 3 equations, 3 unknowns. Try to do it the way you like. C1 plus C3. You can do it by Gauss elimination, by the way. That will be 2. Add these two. I have 2C1 equal 8. So C1 equal 4. Plug it here. So I have 4 minus C3 equals 6. So C3, take it here, take it this one, -2. So I have these solutions, huh? C2 minus 3, C3 minus 2, and where is C1? C1 equal 4. So it will be my solution. Just I plug C1, C2 in this one. So I have C1, huh? My solution, which satisfy both the equation and the condition. I have C1, which is 4, huh? 4, 2ET, 2ET, ET, plus, oops. C2 is what? -201. Huh? C2 is -3. That will be -3. -2 E3T, 0 E3T. Let me check. Yeah, and the last one, 2 minus 2, 1. Okay. So I have C3, which is -2, 2 minus 2 e to the power 5t. And that give me what? 8 ET minus or plus 6 E3T minus 4 E5T. And that will be 8 ET 0 plus 4 E5T. And the last one, 4 ET minus 3 E3T minus 2 A5T. And that, by the way, it's x1 of t, x2 of t, x3 of t. So this is, so my first solution is this one, second solution is this one, third solution is this one. Okay. Yeah, there is x1, x2, not these x1s, huh? I'm talking about a system, huh? As a system. Yeah, so this x1 is different than, yeah, different than the x1 we have there, huh? This. I mean, this x1 is not the same. If I wrote the system, if I wrote x of t as functions, these are functions, these are not vectors, huh? So if I wrote xt as a function, as x1 of t, x2 of t, x3 of t, as functions, then this is the first function, this is the second function, this is the third function. Here, when he wrote x1, he mean the vector. These are the vectors. Okay. There's a difference between this. Okay. This is like capital X1, let me say. This is capital X1, this is capital X2, this is capital X3. Those are not small, the functions. Okay. Yeah, let me do this one to make it clear. Yeah, I think it's the same, not the same exactly, yeah, similar. So this system, if you want to write it as a matrix form, it will be what? X prime. I let, yeah, this is the most important. Let capital X to be X1, x2, x3. These are my solutions. Huh? These are the solutions. As functions. Okay. X prime will be what? 1. No. X prime. Yeah. X1 will be 1. Huh? This is x2. Sorry. This is x2. So it will be 0, 1, 1. Huh? This is x1. It's not clear. 1, 0, 1. This is 1, 1, 0 times x. Okay. He said these are the solutions. These are the solutions of the system. These are solutions x prime equal ax. And this is what I will check. Yeah, let me do this problem, then I will stop. Now, x1 prime, I need to check for x1 now. For x1. Left-hand side, x1 prime. That will be what? It is e to the power 2t. That will be 2 e to the power 2t. 2 e to the power 2t. 2 e to the power 2t. Okay. Right-hand side, that will be ax1. Yeah. 0, 1, 1, 1, 0, 1, 1, 1, 0 times e2t, e2t, e2t. Yeah, I think this question explain what we have in this section exactly. That will be what? And I will explain it to you later. 0, 2 plus 2, 1 plus 1, that 2e2. And this is 2e2, 2e to the power 2t, and the last thing is 2e to the power 2t. Very clear, x1 prime equal ax1. So x1 is a solution. Let me do x2. Now for x2. Yeah, hopefully I have the space. Left-hand side, it will be x2 prime. That will be minus is minus t, 0 is minus t. Okay. Now I have right-hand side, which is ax2. A011, 101, 110 times this is minus t, 0 minus is minus t. Yeah, that give me what? Oops. 0, 0 is minus t. No, b minus is minus t, sorry. 0 times is minus t, 0. 1 times 0, 0. 1 times minus is minus t, it will be minus is minus t. Then I have is minus t, 0 minus is minus t, that will be 0. This is minus t, 0, 0. That's it. Very clear. X2 prime equal ax2. So x2 is a solution. Now for x3. Yeah, what will be left-hand side? X3 prime. That will be 0 minus is minus t is minus t. Now right-hand side, which is ax3. That will be what? 0, 1, 1, 1, 0, 1, 1, 1, 0 times, yeah, 0 minus, oh, not 0 is minus t. Be careful. Yeah. This is my x3, huh? 0 is minus t minus is minus t. If we do the calculation, that will be what? Is minus t minus is minus, that will be 0. Is minus t, 0 minus is minus e minus t. Sorry, let me be careful. 0 times 0, 0. That will be is minus t minus is minus t. That give me what? Yeah. Zero is minus t minus is minus t, that will be 0. Clear. That's it. Now I have 0, 0 minus E is minus T. Yeah, be careful with the calculation. E is minus T, 0, 0. So that will be E is minus T. Very clear, this is equal to this. Okay. So I have x3 prime equal ax3. So that means x3 is a solution. So we solve this. I verify that all of them are solutions. Next one, determine whether the solutions are linearly independent or not. Okay. So check Wronskian of x1, x2, x3. Yeah. What is x1? E2t, E2t, E2t. What is x2? 1, 0, minus 1 with E is minus T. 0, minus 1. Okay. What is the last one? 0 is minus T. Minus E is minus T. I can take e to the power 2t, e to the power minus t, e to the power minus t outside, which is 1, huh? This is 1. That will be 1, 1, 0, 1, 0, 1, 1, minus 1, minus 1. Okay. So I have what? Now I'll do the expansion. Let me say with the third row, with the first row. So I have 1, huh? This is, huh? Ignore it. So I have 1 plus, huh? 1 times, cancel this with this, I have 0, 1, minus 1, minus 1, huh? Minus 1. Cancel this with this, I have 1, 1, 1, minus 1. So that gives me what? Minus 1, minus 1, plus 1, huh? Yeah, that gives me, no, 0. Okay, what is minus 1? I have 0, minus 1, that will be 1. Minus 1 times minus 1, minus 1. So that will be 1. This is minus 2. 1 plus 2, which is 3, not equal to 0. So these are linearly independent. Find the general solution. Notice I have the A is 3 by 3. And I have n linear independent solutions. This is what I need. So this n is 3. And I have x1 and x2 and x3. These are 3. And they are solutions, which is part B. And they are linearly independent. That means the general solution y equal c1 x1 plus c2 x2 plus c3 x3 as vectors. Huh? That will be c1. What is this? e2t, e2t, e2t. The last one, the next one, plus c2 e minus t, 0 minus e is minus t. This is 0 e minus t minus e is minus t. Okay. And plus, no. This is C2, what I'm doing. This is C2 plus C3, the last one. 0 is minus t, minus e is minus t. This C1 times the first one, C1 times X1, C2 times X2, C3 times X3. Now, he wants me to solve this initial problem. By the way, this is the same matrix. Now I have this initial condition. So, don't forget the general solution, X of t, will be C1, huh? Capital X1, that will be E2t, 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 plus C2. What is that? E minus t, 0 minus e is minus t, plus C3. What is that? 0, 1 minus 1. Okay, now I have the conditions. So I have 2 minus 3, 4 equal x at 0. What will be x at 0? Just substitute this. So I have C1. Huh? This is e to the power 0 is 1 plus C2. And the second column, the second row, C1. This is 0 plus C3, sorry, plus C3. The last one, C1 minus C2 minus C3. Yeah. And to solve these equations, and to solve these three equations, so we have these three equations, C1 plus C2 equal to 2, and C1 plus C3 equals to minus 3, and C1 minus C2 minus C3, that's equal to minus 1. That's equal to 4. This is 4, not minus 1, sorry. Is equal to 4. Okay. Yeah. That will be my equation. 1 minus 1 is minus 3. 1, 1, 2. Okay. Yeah, I need to either do it Gaussian elimination. I think it will be easy to do. Let me do it Gaussian elimination. Yeah, since I did the first one, I manipulate the equation. Actually, I can manipulate the equation here, but let me do Gaussian elimination. 1, 0, 1. 1 minus 1 minus 1. This is 4. This is minus 3. What I will do, I try to make these zeros. Yeah, let me write it. Minus R1 plus R2 minus R1 plus R3. That will be 1, 1, 0. Multiply by minus 1 and add, that will be 0. By minus 1 and add, that will be minus 1. By minus 1 and add, that will be 1. By minus 1 and add, that will be 0. Don't forget here. By minus 1, the last one, by minus 1 and add, that's 2. That will be minus 5. Okay. Yeah. Now, by minus 1 and add, that will be 0. By minus 1 and add, that will be minus 2. By minus 1 and add, that's minus 1. By minus 1 and add, that will be 2. Now I change this to plus, minus R2. Have 1, 1, 0, 2, 0, 1, minus 1, 5. Okay, this is the same. Now I need to make this 0. So multiply the second row by minus 2 and add it to the third row. 1, 1, 0. This is 2. I hope I did not do a mistake. 0, 1, minus 1, 5. Multiply, this is 0. Multiply by 2 and add, that will be 0. By minus 2. By 2, sorry. That will be plus 2. 2 and add, that will be 0. 2 and add, that will be minus 3. 2 and add, that will be 12. So I have from this minus 3, C3 equal 12. So C3 equal minus 4. Good. So I have this equation. Yeah, let me write the equation. C1 plus C2 equals to 2. I have C2 plus C3, minus C3, sorry. Minus C3 equal to 5. And the last one, let's write it. Minus 3C3 equal 12. That implies C3 equal minus 4. Plug it here. يعطيني C2 equal what? Minus, that will be 5 minus 4, which is 1. Plug them here. I have C1, 2 minus 1, which is 1. Yeah. Which is 1. So it will be my solution. X of t will be C1 is 1. So I have, yeah, multiply by 1, that will be E2t. The next one, this is write it by a different color. So this is 1, this is 1, this is minus 4. So what I have, A2t, let me go back to my color, A2t plus AT, E minus t here. And then 0, خلاص. Second one, I have A2t. This is 0 minus 4 is minus t. Last one, E2t. Here I have ones. is minus t plus 4 is minus t. That means plus 3 is minus t. These solutions, let me explain what I said before. Let me use this color. This is x1 of t, x2 of t, x3 of t. Well, this is x1, this is x2, this is x3. What I mean by x1, x2, x3, I mean these x1s. These are the functions. Before I go to the matrices, this is what I mean by x1, x2, x3. So these, if you substitute these functions in these three equations, you should get left-hand side equal right-hand side. Okay. Yeah. I think we did good things. By the way, this question, I think, explain everything. What I did, what we did in this section. First we talk about this product rule. This is a product rule for the matrices, to how to find the derivative of the product. I did examples. Then we talk how to write the system into matrix form. And then we did examples about that. And then we talk about how to check its solution. And then this principle of superposition, where they are just a linear combination, is also a solution. Then we talk about Wronskian to check they are linear independent or not. And then we go to the general solution. This is the form for the general solution for the homogeneous systems. Where this question, I think, explain everything. We write the system in matrix form. This is the first things. Then we show there are solutions. And then we determine they are linearly independent. They are linearly independent, actually. They are linearly independent. Okay. And then we find the general solution. And then we use the initial condition to find the C's. He gave us initial condition to find the C's. I think I will stop the recording, and then I will continue in the next slides. Let me stop the recording. Yeah, it's more than 1 hour. Thank you.